A pleasant day, future teachers, specifically the mathematics majors of NUST, and welcome to the Board Licensure Examination for Professional Teachers or BLEP review. And for today, I will be teaching you how to solve questions or problems related to plane and solid geometry. So let's start. The first question is, what type of an angle is an angle which measures greater than 180 degrees but less than 360 degrees? First, let us define the following types of angles. Acute angle is greater than 0 degree but less than 90 degrees. Obtuse angle is greater than 90 degrees but less than 180 degrees. Reflex angle is an angle which is greater than 180 degrees but less than 360 degrees. And linear angle is equal to 180 degrees. And the other one is the right angle whose measure is equal to 90 degrees. So the answer for question number 1 is letter C, reflex angle. Number 2, determine the midpoint of the line segment joining the points 7, -3 and -1, 6. For you to determine the midpoint of the line segment given two points, you have to solve for the x and y. You add x sub 1 and x sub 2, then divide it by 2 to get the x. So you will have 7 plus -1 is equal to 6 divided by 2 is equal to 3. As you look into the 4 choices in this problem, the only letter with x which is equal to 3 is letter C. So right away, you can already answer letter C. But if you want to check if your answer is right or wrong, then you proceed to adding the y's, then divide it by 2. -3 plus 6 is equal to 3 divided by 2 is equal to 3 halves. So meaning our answer is correct, letter C, 3 halves, the midpoint of the line segment. Number 3, R, E, and N are 3 points on a line. The coordinate of R and N are -13 and 77 respectively. If E is the midpoint of Rn, what is its coordinate? This time, we are looking for the midpoint of the line segment given the coordinates of its endpoints. So what we have to do is to add the endpoints, -13 plus 77, that is equal to 64. Then you divide that by 2. 64 divided by 2 is equal to 32. That means the midpoint is letter B, which is 32. Number 4, which among the following statements is always true? A, the supplement of an angle is acute. B, the complement of an angle is obtuse. C, the complement of any acute angle is acute. Or D, 2 supplementary angles are congruent. Let us first define what supplement and complement angles are, or what supplementary or complementary angles are. Supplementary angles and complementary angles are defined with respect to the addition of 2 angles. If the sum of 2 angles is 180 degrees, then they are said to be supplementary angles, which forms a linear angle together. Whereas if the sum of 2 angles is 90 degrees, then they are said to be complementary angles and they form a right angle together. So we move back to this problem, determining which among the following statement is always true. And the answer is letter C. The complement of any acute angle is acute. That is always. Because for letter A, the supplement of an angle is acute. It can be true if the given angle is an obtuse angle, but if the given angle is an acute angle, then its supplement should be an obtuse one. For letter B, the complement of an angle is obtuse. That cannot be because complementary angles, the sum of two complementary angles is only equal to 90 degrees, and that cannot be an obtuse angle. Then for letter D, two supplementary angles are congruent. Not always, because like for example, if the given angle is 20 degrees and its supplement is equal to 160, it can only be true if the given angle is 90 degree, so the supplementary angle is also 90 degree. Only letter C is always a true statement here. Number 5. Two angles are supplementary if the measure of one of the angles is represented by 8x minus 4 and the other one is represented by 2x plus 14. What is the measure of the larger angle? So what we have to do is to add the two given angles. You have 2x plus 14 plus 8x minus 4. You equate that to 180. Then simplifying it further, you will have 10x equals 180 minus 10, which is equal to 170. Divide the whole equation by 10, so x now equals 70. So we are not done yet because the question is, what is the measure of the larger angle? What we have to do is to substitute 17 into the given algebraic expressions. So you will have 2 times 17 plus 14 is equal to 48. That's the measurement of one of the angles. And then the other one is 8 times 17 minus 4, which is equal to 132. So the measurements of the two angles are 48 and 132. So the larger one measures 132, and that is letter B. Number 6. Which of the following statements is or are true when two coplanar lines are being cut by a transversal line? 1. Vertical angles are congruent. 2. Alternate exterior angles are congruent. 3. Corresponding angles are congruent. 4. Same side interior angles are congruent. So the first thing that we have to do is to review what transversal line is all about. So in this case, the transversal line is the blue one, this one, and these two lines are the two coplanar lines, which is being cut by a transversal line. When that happens, when the transversal line cut the two coplanar lines, different angles will be formed. As you can see, we have 8 different angles here, and there are relationships existing between and among these angles. The first one, we have the interior angles. Interior angles are 3, 4, 5, 6. Those angles inside the transversal. And exterior angles are those angles outside the transversal, which are 1, 2, 7, and 8. Pairs of alternate exterior angles. Alternate exterior, meaning we are dealing with exterior angles. We have 1, 7, then 2, 8. As you can see, they are alternate exterior angles, and alternate exterior angles are congruent, meaning if the measurement of angle 1 is 110, angle 7 is also 110. If the measurement of angle 2 is for example, 45, then the measurement of angle 8 is also 45. Alternate exterior angles are congruent. Next, alternate interior angles. You have 4, 6, then 3, 5. And alternate interior angles are also congruent. Then we have 3, 5 here. Next, we have pairs of corresponding angles. Corresponding angles meaning one in the exterior and one in the interior of the transversal, but they lie on the same side of the transversal line. We have 1, 5, then 4, 8, 2, 6, and 3, 7. So all these are pairs of corresponding angles, and corresponding angles are congruent as well. Next, pairs of angles on same side of the transversal. Pairs of angles on the same side of the transversal. We have 3, 6, and 4, 5. 3, 6, and 4, 5. Same side of the transversal angles are supplementary. They are not congruent. Meaning, if you add the measurement of angle 3 and measurement of angle 6, the sum is equal to 180 degrees. So we move back to the problem. From these statements, which of the following is or are true? Vertical angles are congruent. So this is actually a general knowledge. Vertical angles are congruent. Even though it is not in the transversal line, in the transversal, we know that vertical angles are congruent. So 1 is true. Number 2, alternate exterior angles are congruent. That's true. Corresponding angles are congruent. That's true also. Same side interior angles are congruent. This is not true. Meaning, the only true statements here are 1, 2, and 3, and that is letter C. Number 7. Applying the concept of betweenness and collinearity of points, given that L, J, and R are 3 collinear points, which of the statements is true? J is between L and R is between J and L. That cannot be true because if J is already in between L and R cannot be in between J and L already. Letter B, J is between R and L, and J is between L and R. So letter B is a true statement here because J is in between R and L, so that it can be in between L and R. So letter B is the correct answer. Number 8. How many lines can be drawn through 6 non-collinear points? Alright, so you have here 6 non-collinear points. 1, 2, 3, 4, 5, 6. Then we connect it, we form a hexagon. So we already have 6 lines. And then we connect the non-collinear points one by one. So you have 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 lines that can be drawn through 6 non-collinear points. The answer is letter C. But what if the given number of non-collinear points become a little bit higher? Like for example, you have 21, 30, then you have to use the formula already. N times the quantity of n minus 1 divided by 2. So let us check if this formula can be applied. You substitute 6 into n because n stands for the number of non-collinear points. 6 times the quantity of 6 minus 1 divided by 2. So you will have 6 times 5, which is 30 divided by 2. That is equal to 50. Number 9. what would be the measurement of the exterior angle adjacent to the base angle of an isosceles right triangle? So here is an example of an isosceles right triangle. If we extend this side from here up to here, infinity, will be forming the exterior angle. The exterior angle which is adjacent to the base angle of the isosceles right triangle. Actually, this is the base of this isosceles right triangle, and this is the vertex. Okay, the right angle is the vertex of this right triangle. If you extend this line, you will be forming the exterior angle adjacent to the base angle. And if this is 45 degrees, then the measurement of this angle would be 180 minus 45, and that is equal to 135. 180 because these two angles, the exterior angle and the base angle, are linear pairs. They formed 180 degrees. For you to get the measurement of the exterior angle, you have to subtract 45 or the base angle from 180, and that is equal to 135, or letter D. Number 10. The vertex angle of an isosceles triangle is 20 degrees. What is the measure of one of the base angles? Alright. So given the vertex angle of an isosceles triangle, let us first define what isosceles triangle is. Isosceles triangle is a triangle with two equal sides so that the two angles are also equal. A sort of review, equilateral triangle is a triangle with three equal sides and so three equal angles, and that is always 60 degrees. The measurement of the angles of an equilateral triangle is always 60 degrees. A scalene triangle, no equal sides, so no equal angles. So we focus into isosceles triangle here. Two sides are congruent, so two angles are also congruent. Given that this is 20 degrees, if this is 20 degrees, and we know that the sum of the three angles of a triangle is equal to 180 degrees, 180 minus 20 is 160. 160 divided by 2 is 80 degrees. So that means the measurement of the base angles of an isosceles right triangle with 20 as its vertex angle is 80 degrees, or letter D. 11. Two buses leave the same station at 8 p.m. One bus travels north at the rate of 30 kph and the other travels east at 40 kph. How many kilometers apart are the buses at 10 p.m.? Alright, so take note of the given. We have to know that one of the buses, the direction is to north and the other one goes to the east. Then we are looking for the distance of the two buses at 10 p.m. after 2 hours that they are traveling given a certain speed. So you have to start with the Pythagorean theorem, a squared plus b squared equals c squared, and then put in what we know, or put in what is given. So you will have 60 squared. Why 60 squared? Because one of the buses travels 30 kph, 30 kilometers per hour. So after 2 hours, the bus already hit 60 kilometers. And the other one travels 40 kph. So it's already 80 kilometers that the bus traveled after 2 hours. That is why you'll have 60 squared plus 80 squared is equal to c squared. And then we simplify it further. We calculate squares. You'll have 3,600 plus 6,400 is equal to c squared. You add, that's equal to 10,000 equals c squared. Then solve for c. You square both sides of the equation. C is equal to 100. Meaning, the distance of the two bases at 10 p.m. is already 100 kilometer using the Pythagorean theorem. Number 12. If the sides of two similar triangles are in the ratio of 4:8, find the ratio of their areas. Take note that if two polygons are similar, the ratio of their areas is equal to the square of the ratio of their corresponding sides. Meaning, we have to get the square of 4 and 8 to get the ratio of their areas. And the square of 4 is 4 squared is equal to 16 and 8 squared is equal to 64. So that 16 is to 64 or letter D. Number 13. The measurement or the measures of the width and diagonal of a rectangle are 6 feet and 10 feet respectively. What is the area of the rectangle in square inches? Okay. So here's the rectangle and the diagonal. The measurement of the width is 6 and the diagonal is 10 feet. So we have to look for the length of the rectangle for us to determine the area. Okay? So we use the Pythagorean theorem once again. A squared equals c squared minus b squared. We substitute the values. So we have a squared equals 10 squared minus 6 squared. So a squared is equal to 100 minus 36. That is equal to 64. You square both sides of the equation. A is equal to a. So the length of the rectangle is equal to 8 feet already. But take note that we are looking for the area of the rectangle, which is in square inches. So what we have to do is to convert feet into inches. So 6 feet is equal to 72 inches and 8 feet is equal to 96 inches. Then we solve for the area of the rectangle applying the formula length times width. That is equal to 96 times 72, which is 6,912 square inches, or letter D. Number 14. One side of a 45 by 45 by 90 triangle measures x centimeter. What is the length of its hypotenuse? Alright, this is the isosceles right triangle. As you can see, we have two equal sides here. Two equal sides, 15 and 15. So the hypotenuse is 15 the square root of 2. That is actually how we solve for the hypotenuse of a 45 by 45 by 90 triangle. You simply multiply the measurement of the side by the square root of 2. So if the measurement, for example, of this side is 7, then the hypotenuse is 7 the square root of 2. Meaning, if the measurement of the side is x, then the measurement of the hypotenuse is x the square root of 2, or that is letter D. 15. Which of these has the longest perimeter? This type of problem is a problem that you have to solve each one of the choices because you have to be very sure with your answer. Okay. Letter A, a square 21 centimeter on a side. So you have to solve for the perimeter. You add all the sides of the square. So 21 plus 21 plus 21 plus 21, that is equal to 84 cm. A rectangle 19 cm long and 24 cm wide. So the perimeter is 2 times 19 plus 2 times 24, which is 86 cm. Letter C, an equilateral triangle whose side is 28, meaning 28, 28, 28, you add, that is 84. Then letter D, a right triangle whose two legs are 24 and 32. So you have to solve first for the hypotenuse. Actually, this type of problem is a problem that requires you to just use your common sense. So suppose that the measurement of one of the sides of the triangle, or the hypotenuse, which is the longest side of the triangle, suppose that that is 33. Suppose that that is 33, which is greater than 32. Then you add 24 and 32, that is equal to 56 already, plus 33. So that makes you, or that gives you 89 already, even if you only assume that the hypotenuse is 33, because you know that hypotenuse is the longest side of the triangle. So the correct answer here is letter D. Number 16. A square has an area of 400 square centimeter. What is the perimeter? Given the area of the square. And we know that for us to get the area of the square, we simply get the square of each side. So for us to get the side of the square, we simply get the square root of the area. And the square root of 400 is 20. So side is equal to 20. But we are not done yet, because the question is, what is the perimeter? Perimeter is 4s, or 4 times side. 4 times 20 cm is equal to 80 cm, which is letter B. 17. What is the value of x in the figure below? Here's the figure. Our task is to solve for x. We may use subtraction here. 23 minus 15 is equal to 8. 8 divided by 2 is 4. So this would be 4, and this is also 4, because we know that this segment from here up to here and this segment are congruent. So if this is 15, this is also 15. If the whole segment is 23, so these two segments should have an equal part. 8 divided by 2 is equal to 4. So we already have the measurement of this segment, which is 4. We can now solve for x using the Pythagorean theorem. By substitution, we will have a squared equals 10 squared minus 4 squared. Simplifying it further, you'll have 100 minus 16, or a squared is equal to 84. Using your calculator, you will have a equals 9.165. So the answer is letter B. Mind you that we mathematics majors are very lucky, because we are allowed to use non-programmable calculator during our majorship in the board for licensure examination for teachers. Meaning, you have to use your calculators already at this point in time for you to be really very familiarized with the functions of your calculator. Number 18. In the diagram, DE is parallel to AC. Here, DE is parallel to AC. Then BD is equal to 4. And DA is equal to 6. And EC is equal to 8. Find BC to the nearest tenth. Right. So as you can see, from this figure, we can form a proportion. BD over BA. BD, this portion, over this whole segment is equal to BE over the whole segment also, over BC. And then we put in the values. So we set x, we set BE equals x. So we'll have BD, which is 4, then BA is 10, 10 because 4 plus 6 is 10. And then, if BE is x, then BC is 8 plus x, or x plus 8. Then we simplify it further. By cross multiplication, we'll have 4 times x plus 8 equals 10 times x. So you will have 4x plus 32 equals 10x. Simplifying it further, we solve for x. 6x equals 32. Then x is 5.3. Meaning, BE is equal to 5.3 already. This is 5.3. But mind you that we are tasked to solve for BC. Meaning, we have to add 8 to 5.3 to get the measurement of BC. So BC is 13.3, which is letter D. Number 19. 2 ladders are leaned against a wall such that they make the same angle with the ground. The 10-foot ladder reaches 8 feet up the wall. How much further up the wall does the 18-feet ladder reach? Ayan. Letter A, 6.4. Letter B, 8.4. Letter C, 10.4. Then letter D, 14.4. What you have to do here is to, again, make a proportion out of the given. From this figure, we can say that 18 over 8 plus x, 18, this hypotenuse, over 8 plus x. Since this is x, if this is x, then this whole segment is 8 plus x, equals 10, the hypotenuse, over 8. Then we simplify this by cross multiplication. You will have 10x plus 80 equals 144. Then solve for x. 10x equals 64, or x is equal to 6.4. And that is the measurement of this portion. Then we add 8 to 6.4. 6.4 plus 8 is equal to 14.4. So the answer in number 19 is 14.4. The measures of the height and base of a right triangle are 20 inches and 21 inches respectively. What is the perimeter of the triangle? Alright. So given the height and base of the right triangle, take note that these take note of the Pythagorean triples. Okay, so you really have to be very you have to become a wide reader when it comes to mathematics also. Sometimes you have to take note of some trivias like the Pythagorean triples. So 20, 21, and 29 are Pythagorean triples, meaning 20 and 21 are the height and base of the right triangle, and 29 is the hypotenuse. And then, to solve for the Pythagorean, to solve for the perimeter of the triangle, you simply add all those three, 20 plus 21 plus 29, that is equal to 70. So the perimeter of the triangle is 70 inches, or letter B. For number 21, what is the area of the triangle below? Okay, take note that the formula in solving for the area of a triangle is 1/2 of the base times the height. Given the base, which is 7 meter, and the height, which is 5 meter, simply substitute those values into the formula and then simplify it further. So A is equal to 17.5 square meter, which is letter C. Number 22. What is the measure of the other angle in this figure? Take note that the sum of all the angles of a given quadrilateral is equal to 360 degrees. Given the measurement of the three other angles, you can now solve for the unknown angle, angle K, by simply subtracting all these measurements from 360. So K is equal to 360 minus 293, and that is equal to 67. Meaning, K is equal to 67 degrees. Number 23. ABCD is a rhombus. What is X? Take note that diagonals of a rhombus are perpendicular, meaning they formed right angle. So that we may say that 9x is equal to 90. The measurement of this angle is equal to 90. Then we solve for x. X is equal to 10, or letter A. Number 24. JKLM is a rectangle. What is X? Given that JL is equal to 4x plus 2 and MK is equal to 5x minus 1. These are both diagonals of the rectangle. And diagonals of a rectangle are congruent. So we can equate JL equals MK, or 4x plus 2 equals 5x minus 1. Then we solve for x, which is equal to 3. That is letter C. And then if you want to check if your answer is right or wrong, you simply substitute the value of x that you get to the first equation that we have. So you will have 14 equals 14. So the answer that we get is correct. Actually, in mathematics, you really have to double check your answers because sometimes there are questions which are very tricky. So you better watch out. 25. What is the area of the square? Given that ZW is equal to 2x plus 4 and WX is equal to 3x minus 2. Alright, so these are sides. And take note that all sides of the square are congruent. So we can equate these two. 2x plus 4 is equal to 3x minus 2. Solve for x, you will have 6. So that is already the measurement of, that is the value of x already. And then you substitute x into the x. You will have 2 times 6 plus 4. That is 16. 16 is the measurement of the side now. We can now solve for the area of the square. Area is equal to s squared, and 16 squared is equal to 256, or letter D. Number 26. What is the area of the trapezoid? A, 60, B, 24, C, 32, D, 64. As you can see here, we have a trapezoid with 2 bases, and the measurements are 10 and 6 respectively, and the height is 8. The formula in finding the area of a trapezoid is median times the height. How do we solve for the median? We add the 2 bases, then divide it by 2. So you have 6 plus 10, which is 16, divided by 2 is 8. So median equals 8. Then moving back to the formula of finding the area of a trapezoid, you'll have median, which is 8, then height, which is also 8. So 8 times 8 is equal to 64, meaning the area of the trapezoid is 64. Next, number 27. The figure below is a parallelogram. What is the value of a known variable y? Take note that in a parallelogram, opposite sides are congruent, meaning this side and this side are congruent. This side and this side are congruent as well. So from here, we can say that x is already equal to 12 because they are equal. X is equal to 12. So we already have the exact value of x. We can now equate the other pair. 7y minus 3 equals 3x plus 3. Then substituting the value of x that we have, you'll have 7y minus 3 equals 3 times 12 plus 3. 7y is equal to 42. Then you solve for y, divide the whole equation by 7. Y is equal to 6. And that is letter C. Number 28. The figure below is a parallelogram. What is the measurement of the longer diagonal? Diagonals of parallelograms bisect each other, meaning they divide one another into two congruent segments. Y minus 1 is equal to x, then 4x plus 1 is equal to 3x plus 5. So we can equate that. 3x plus 5 is equal to 4x plus 1 to solve for x. So x is equal to 4. Then we equate the other one, y minus 1 equals x. Then substitute the value of x that we have here. Y minus 1 is equal to 4. Then y is equal to 5. And then substitute the value of x that we have into here. So you will have 3 times 4 plus 5 is equal to 17, since we are looking for the measurement of the longer diagonal. So that means this segment measures 17 plus another 17. This is 34. Okay? So we multiply that by 2 to get 34, because these two segments are congruent. If this is 17, then this is also 17. So the answer is 34. 29. A square has a perimeter of 36 inches. Find the length of the diagonal. Alright. So side is equal to 36 over 4 equals 9, because we know that for us to solve for the perimeter of a square, that is 4s, we multiply the side by 4. So to get the side given the perimeter, we simply divide the perimeter by 4 to get the side. So side is equal to 9. Next, find the length of the diagonal. So we apply the concept of a 45 by 45 by 90 right triangle. If the measurement of the side is 9, then the measurement of the hypotenuse is 9, the square root of 2. And simplifying this using your scientific calculator, you'll have 12.72792206 and so on. And that is equal to letter A, 12.73. Take note of the rounding off. So this is the correct one, 12.73, because next to 2 is 7, so we have to round it up. Number 30. In parallelogram frag, measure of angle G is 2x plus 10 and measure of angle R is 8x minus 30. Find the value of x to the nearest 100. As you can see here, angle G and angle R are opposite angles. They are non-consecutive letters into the parallelogram frag. So that means they are opposite angles. And opposite angles of a parallelogram are congruent. So we can equate 2x plus 10 and 8x minus 30. Then we solve for x. 6x equals 40. Then x is equal to 6.67. Okay, so the value of x is 6.67, or letter A. 31. Using the given in item number 30, what is the measure of the parallelogram's larger angle? So you will be moving back to given number 30. The question is, what is the measure of the parallelogram's larger angle? So what you have to do is to substitute x into 2x plus 10. So you will have 2 times 6.67 plus 10. That is 23.33. So if the measurement of angle G is 23.33, the consecutive angle to angle G is the supplementary angle to angle G measures 180 minus 23.33, and that is 156.67, or letter A. Number 32. In parallelogram ABCD, the measure of angle A exceeds the measure of angle B by 28 degrees. Find the measure or find the degree measure of angle C. Okay. Let angle B equals x and angle A be equal to x plus 28. And take note that angle A and angle C here are congruent because they are non-consecutive angles of a parallelogram. Consecutive angles are supplementary. Angle A and angle B are consecutive angles, so they are supplementary, meaning that their sum is equal to 180 degrees. So we add x plus 28 is equal to 180. Then 2x is equal to 152. Then solve for x is equal to 76. That is the measurement of angle B. Then to solve for the measurement of angle A, you simply add 28 and that is equal to 104. And as I mentioned earlier, angle A and angle C are non-consecutive angles, and non-consecutive angles are congruent, meaning if angle A is 104, then angle C is also 104. Number 33. In square RSTU, the measure of angle R is 3x plus 33. What is the value of x? Take note that all angles of a square are right angles, meaning angle R is a right angle. So we can equate 3x plus 33 equals 90. Then we solve for x. 3x is equal to 57. X equals 19, or letter C. Number 34. Which of the following cannot be the measurement of a minor arc? Let's just have a short recap on the different types of arcs that we have. We have the minor arc, semicircle, and major arc. Minor arc measures greater than 0 but less than 180. So definitely the measurement that cannot be the measurement of a minor arc among these choices is letter D, which is 181, because it's greater than 180 already. Semicircle is equal to 180, then major arc is greater than 180 but 360. Letter A is a minor arc, B is a minor arc, C is a minor arc, and D is a major arc. So the correct answer for 34 is B. 35. The measurement of the central angle is 78 degrees. What is the measurement of its intercepted arc? Alright. Here's a central angle. A central angle is an angle formed by two radii. And central angle is equal to intercepted arc. Meaning, the measurement of this angle, the measurement of the angle formed in the circle is equal to the length of its intercepted arc. So if this is 50, then this is also 50. If this is 78, then the measurement of the intercepted arc is also 78. So if the central angle is 78, intercepted arc is what? 78. Number 36. If the intercepted arc of an inscribed angle measures 90 degrees, what kind of angle is the inscribed angle? This time we have the inscribed angle. What is inscribed angle all about? Okay, here's an inscribed angle. An inscribed angle is an angle formed by two chords of the circle. They formed an angle here. Then that is what we called an inscribed angle. And this arc is the intercepted arc of the inscribed angle. Here we have the inscribed angle is equal to 1/2 of the intercepted arc. Meaning, for you to get the measurement of the inscribed angle, you have to multiply the measurement of the intercepted arc by 1/2. Meaning, if the intercepted arc is 100, then the inscribed angle is equal to 50. Here, the intercepted arc is 90 degrees, so the inscribed angle is 1/2 of 90, which is 45. What type of angle is 45? That is an acute angle, or letter D. Number 37. In the figure below, Rn is a diameter. Chords IR and EN are congruent and angle NSD equals 58. Arc FD equals 64. Find angle RSF. So the first thing that we have to do is to identify all the given. There, NSD is 58, that's angle. And then the intercepted arc is 64. So that means the measurement of this angle DSF is also 64 because this is a central angle and the intercepted arc is given, which is 64. So you can say that this is 64 as well. And our task is to look for RSF. So take note that NSD plus DSF plus RSF is equal to 180 because they formed a line. So we may say that when we add all these three, the sum is equal to 180. And then we put in all the given, the known values. NSD is 58, then DSF is 64. Then we are looking for RSF. You solve for that, doing some algebraic manipulation here, RSF is equal to 58. That is letter C. Number 38. If an angle formed by 2 seconds intersecting in the interior of the circle measures 32 and one of its intercepted arcs is 50 degrees, what is the measure of the other arc? Okay, let's illustrate the problem. As you can see here, we have 2 secants intersecting and formed angles inside. Actually, these are chords. Okay, but if you extend the chords, you will be having secants. They formed angles inside the circle. And if that happens, some conditions will be formed. For angle 1 is equal to 1/2 of the measurement of the sum of its 2 intercepted arcs. So BC plus AB divided by 2 to get the measurement of angle 1. In this case, angle 1 is equal to 32 because that is the measurement given already. And then the measurement of one of the arcs is also given, which is 50 degrees. So our task is to solve for arc BC. So measure of angle 1, applying this condition, you will have measure of angle 1 is equal to 1/2 of the sum of the 2 arcs. Then putting in all the known values that we have, measure of angle 1 is 32 equals 1/2 of arc 1, which is 50, plus arc 2, which is the unknown one. To eliminate the fraction 1/2, we multiply the whole equation by 2. So you'll have 64 equals 50 plus arc 2. Then solve for arc 2, you will have 14 because 64 minus 50 is equal to 14. And the answer here is letter A. Number 39. If the intercepted arcs of the angle formed by 2 seconds intersecting outside the circle are 45 and 120 degrees respectively. So this is another type of condition because the 2 seconds intersect outside the circle. What is the measure of the angle? So we visualize the problem. Here, 2 secants intersect outside the circle. So the condition would be the measurement of this angle is equal to 1/2 of the difference of the 2 intercepted arcs. This arc and this arc. To get the difference, then divide that by 2. So given that one of the arcs is 45 and one is 120, you will be having measure of angle 3 is equal to 1/2 of the arc 1 minus arc 2, or that is equal to 1/2 of 75, and 75 divided by 2 is 37.5, or letter B. Number 40. The measure of the angle formed by two secants intersecting outside a circle is 47 degrees. If the sum of the measure of the intercepted arc is 282 and the bigger arc is twice the smaller, what is the measure of the larger arc? So we visualize again. That's the same problem with the previous one. Two secants intersecting outside the circle. So angle 3 is 47 degrees. The angle measures 47 degrees, and then we are looking for the measurement of the larger arc, given the condition that their sum is equal to 282, and the bigger arc is twice the smaller. So we let x be equal to the smaller arc and 2x be equal to the bigger arc. Then we add the 2, that is equal to 282 as stated in the problem. Then solving for x, you will have 94. So this is actually the measurement of the first arc, the smaller arc. To get the measurement of the bigger arc, you simply multiply that by 2, and that is equal to 188, or letter C. If you want to check if your answer is right or wrong, you apply this given into the condition, and you will be arriving at the correct answer. 41. What is the radius of the circle if its area is 113.04? The area of the circle, take note, is pi r squared. So we substitute the known values. We have 113.04, which is the area, and pi is 3.14 r squared. So r squared is equal to 36, because 113.04 divided by 3.14 is 36. We get the square root of the both sides of the equation, so r is equal to 6. Radius is 6. 42. The edges of a rectangular solid have these measures: 1.5 feet by 1.5 feet by 3 inches. What is its volume in cubic inches? So the first thing that we have to do is to convert those dimensions in feet to inches. So 1.5 feet is equal to 18 inches. 1.5 feet is 18 inches. Then you solve for the volume. You multiply the 3 dimensions, 18 by 18 by 3, and that is equal to 972, or letter C. 43. How many vertices does a hexagonal prism have? And here's the hexagonal prism. The question is how many vertices. So this is a hexagon. So on top we have 6 vertices, and then at the bottom we also have 6 vertices. So all in all we have 12 vertices. 44. What is the lateral area of the pentagonal prism below? So here is the pentagonal prism with the following dimensions. As you can see, the side of the pentagon is 3 inches and the height of the prism is 5 inches. So lateral area is equal to perimeter of the base times the height. So we have to find the perimeter first of the base. Perimeter is 3 plus 3 plus 3 plus 3 plus 3. That's 5 threes, which is equal to 15. And then you multiply that to 5. Lateral area is equal to 75. Take note of the formula in finding the lateral area of prism. Lateral area is always equal to the perimeter of the base times the height. Now, a solid is an octagonal prism. How many base edges are there in all? So here is an octagonal prism. The question is how many base edges are there in all. So So we just focus into the base edges. On top, of course, we have 8 edges, and then at the bottom we also have 8 edges. So adding 8 and 8, you'll have 16, which is letter C. 46. Find the total area of the right triangular prism. Alright, so here is the right triangular prism, and our task is to solve for the total area, meaning the areas of all the faces of this triangular prism. So what we have to do is to find the area of the two triangles, which are the bases of this solid, plus the area of the three different rectangles, which are the lateral surface area or lateral surfaces of the solid. Solving for the area of a rectangle, you will have 8 times 15. 8 times 15, this first rectangle, and then the area of the second rectangle at the right side, and the area of the rectangle at the left side. So you will have 8 times 15 plus 8 times 14 plus 8 times 13. Area of the three rectangles is 336. And then to solve for the area of the triangle, take note that these two triangles are congruent, so we have to solve for the area of the one of the triangles, then just multiply it by 2 afterwards. Using the Heron's formula to find the area of each base, this formula, where S is equal to 1/2 of the sum of the three sides, and that is equal to 21. Then substitute 21 into this formula, the Heron's formula, and you will be getting the area of the base, which is 84. And take note that we have two triangles here, so we multiply 84 by 2 and then add 336, that is equal to 504. So the total area of this triangular prism is 504. 47. The total area of the right square prism is 210 square centimeters. Find the length of a side of the square base if the altitude of the prism is 8 centimeter. Take note the total area once again is equal to the areas of all the faces. So from here, given the total area, which is 210, that is equal to the area of the two squares, so that's 2x squared, because the area of this square is x squared, the area of this square is x squared also. You multiply that by 2, so that's 2x squared. And then the area of the rectangles, we have 4 rectangles, 8 times x is 8x, then multiply that by 4 since we have 4 rectangles. Then simplifying this further, you will have 2x squared plus 32x minus 10. And then we solve for x by factoring. Okay, or we simply simplify this first, divide the whole equation by 2 for you to become a little bit, for it to become a little bit easy or easier to solve, to manipulate the algebra. So you will have to factor x squared plus 16x minus 105. The factors are x plus 21 times x minus 5. Then you solve for x. One of the x's is negative 21 and one of the x's is equal to 5. Of course, since we are looking for the length of a side, this is a length, so it should be positive. We take positive 5. So the answer is letter C. Number 48. Find the volume of a box whose dimensions are 1 foot, 8 inches, and 10 inches. Letter A, 80, B, 960, C, 145, D, 350. So once again, the first thing that we have to do is to translate or to convert dimensions into same units. 1 foot is equal to 12 inches. And then we find the volume already by multiplying the dimensions. So you have 12 inches by 8 inches by 10 inches is equal to 960 cubic inches, or letter B. 49. How many faces does a pentagonal pyramid have? So here is the pentagonal pyramid. It has 6 faces with 10 edges and 6 vertices. So the correct answer is letter B. And then the last question, if D equals 4 cm and H equals 3.5 cm, find the approximate volume of the right circular cylinder. Alright. So the formula in finding the volume of a cylinder is pi r squared times height. Given the diameter and the height, we simply substitute the given values into the formula. Volume is equal to 3.1416 times 2 because we are using the radius. So to get the radius given the diameter, you simply divide it by 2. So you have 2 squared times height, which is 3.5. Simplifying that further, you will have volume equals 43.9824, or letter A. And that's it. With my 1 heart, 2 eyes, 5 liter of blood, 206 bones, 1.2 million red cells, 60 trillion DNAs, I wish you all the best. Put your best effort on the exam and God will surely crown you with success. My good wishes will always be with you. Best of luck, future teachers, future LPTs, and future top notchers from NUST.